In this video, I'll show you how to fit a model to dat1, the first data set. So the first step when modeling field trial data with this dat1 star package is creating an object of class called TD. And this TD object is used as an input for analysis in this package. Okay, so let's create the TD object for the first data set. So we'll use a function called createTD. And let's call this TD object data TD1 and then create TD object. Okay. And first we need to specify the data. So the data is equal to data 1.1. Okay. Remember we removed the outliers. So the new data set is called data 1.1. And what are the other arguments? Let's take a look at the manual of this function createTD. So we can just put question mark here and then put the function name createTD. And here is the help manual of this function. So how does this createTD function create a TD object? Okay. So the first step, you need to put the data set. So put data set here, and then it rename the columns to the default column names. Okay, and the default column names in this function are genotype, trial, location, year, and so on. And then it converts column types to default column types. For example, the row coordinates and column coordinates are converted to numerical columns, and all other renamed columns are converted to factor columns. And then it splits the input data by trial. Since we have multiple trials, so each trial in the input data will become a list item in the output. So actually, a TD object is a list with some items where the number of items is just equal to the number of the trials. So let's rename the columns. The first one, genotype. Okay. So in data 1, the column's name for the genotype is called identity 1. So put identity 1 here. And the next one, trial. So trial is the block column. Okay. And then we don't have location, we don't have year. And for rep ID and subblock, we can do it later. Let's first put the row coordinates and column coordinates there. So the row coordinate is equal to p row. And column coordinate is equal to prng. Next, we can put plot ID here, but it's not necessary to put plot ID for this one, but anyway, let's do it. And the subblock is equal to, let's put subblock as the sub experiment, so it's expd variable. Okay. Then I think we are done. So you can see here, the TD object data TD1 is a list with 4 elements because there are 4 trials in this data set. And if you want to recall the names of the trials, you can simply use the names function. So you can see the 4 trials are just named 1, 2, 3, 4. Why do you want to do this? Because in the next steps, when we do summaries and like plots, we need to specify like which trial we want to get a summary of or we want to plot. So here, sometimes we may want to help us to recall that what are the names of the trials. Okay. And after creating a TD object and data for new trials, if you have data for new trials, they can be added to it using the function called addTD. Okay? And this function basically works in exactly the same way as createTD function, except that it adds data to an existing TD object instead of creating a new one. And if you want to remove trials from an existing TD object, you can use the function called dropTD. So once we have the TD object available, we can use the summary function to get an idea of the content of the data in the TD object. The summary function, first we need to put the TD object there. So the TD object is TD1. And then, since we have multiple trials, we need to specify which trial we want to summarize the data of. So let's say we want trial 2. Okay. And in addition, we also need to specify which trait we want to get a summary of. So here, let's say we want to get the summary of the yield variable, like 5. Actually, we can get a summary of multiple traits at once, but for simplicity, let's just do that for a single trait. Okay. Let's see what we get. Okay. So here you can see there are some summary statistics here. We have mean, median, min, max, font house. Basically, these are the 5 number summaries and the variance. And in default, the summary function gives you 9 summary statistics, but actually many more are available. Let's take a look at the menu of this summary function to see what other summary statistics are available. Summary.td. So you can see there's an argument called what. And this argument is a character vector indicating which summary statistics should be computed. And if we set what equal to all, then all available statistics are computed. And here are some other possible options. Okay, you can see you can get the coefficient of variation, the standard error of variance, the sum, the skewness. Okay. And okay, let's try once. So let's say we just want to get the mean and median. TD1, again try equal to 2, and traits. What? Let's say mean and median. Okay, so mean. Remember that it has to be characters. Okay, now you can see we only get mean and median. And in addition to numerical summaries, we can also get zero summaries using the plot function. So if we plot TD1, and the default plot creates plots for the layout of all trials in the TD object, but this can be restricted to selected trials using the trials parameter. So again, so we want to get the plot for the second trial. You can see here's the layout of the trial 2. And this plot can also be extended by highlighting some interesting genotypes in the layout. So let's do that. Data TD1, trials 2. And for example, we want to highlight 2 genotypes,
which are C2 and G1012. As you can see, these 2 genotypes are highlighted in this plot in red and blue. It is also possible to color the subblocks within each trial by setting the argument color subblock equal to true. Okay. And let's try that. Again, trials equal to 2. And we set color sub block equal to true. And let's zoom it in.
and you can see here there are this many subblocks, and each blocks are displayed in different colors. Okay.
And finally, it is also possible to show the names of the genotypes on the plot using the argument called show genome. So we do plot, same thing. And then we put show genome equal to true. Here, you can see that the names of these genotypes are displayed on this plot. In addition to the plot of the layout, we can also make a box plot of the TD object. Again, we use the plot function, data TD1. Then we set plot type equal to box. Okay. And we need to specify the traits. Okay. So traits equal to this. So basically, it creates a side-by-side box plots for each of the 4 trials, 1, 2, 3, 4. Okay.
So after creating a TD object, we can fit a model to the data using the function called fitTD. And the exact model fit depends on the design of the trial. And the design can be given as a parameter or an argument in the function fitTD. And as I mentioned in the introduction of the package, the fitTD function uses 3 different engines for fitting the models. And they are SPATS, LME4, and SREMO. And for models with row column or resolvable row column design, the SPATS is the default engine. And for the other models, LME4 is the default. And models can actually be fit for 5 different trial designs for this package. And here is a table showing the 5 trial designs and their respective model specifications. Okay? So the 5 trial designs are incomplete block design, resolvable incomplete block design, randomized complete block design, row column design, and resolvable row column design. And these are their corresponding codes we need to put into the function when we specify the designs. And here are the models. And the fixed effect is actually indicated in italics. Okay, so for example, this rep ID is actually a fixed effect, and these terms that are in bold are random effects. So subblocks, row ID, column ID. Okay, and genotype can actually be fitted as fixed or random effects depending on the value of the parameter what. So we can put an argument called what there to indicate whether you want to fit a model with genotype as a fixed effect or random effect. Okay. So let's do it. Let's fit the model for the data TD1 object. Okay. So let's call the model model1 with TD function. And the first thing we need to put is the TD object, the name of the TD object. Okay. So it's called data TD1. And then we need to put traits. Okay. So the traits is equal to the yield variable. Then, so let's use the row column design for this data set. And let's use ng equal to specs. Okay. And here we want to use genotypes as fixed effect. So we set what equal to fixed. So if you don't specify this what argument, you don't put what here, then it will automatically fit two models, one for the model with genotypes as fixed and the other one for the model with the genotypes as random effect. Okay. It actually takes some time to get the result. And here it is. We have a fitted model, and to get a summary of the fitted model, we could again use the summary function. Okay. So use summary model 1, and since we didn't specify which trial we want to fit a model on, so actually it fit a model for each of the 4 trials separately. So when we want to see a summary of a model, we need to specify the trial. So we need to tell the function which trial we want to see a summary of. Okay. So let's say we want to see again the trial 2. And what are the other arguments? Let's take a look at the manual of this function, STA. Okay. So our trials as trait. So actually we because since we have already specified the traits here, when we fit the model, so we don't have to put trait there because it will automatically choose the same trait as the in this function. Okay. And there's another argument called n best. So what is this? So n best is an integer indicating the number of the best genotypes to print. Because in this function, it will gives you a number of best blues or blobs. So you can specify like how many how many of the best genotypes do you want to see. Okay. So if you put NA, all genotypes will be printed. Okay. So let's put best equal to 5. Say we just want to see the 5 best genotypes.
First, it again gives us summary statistics for BUAC5 in trial 2, like what we saw in the summary of the TD object. Next, it provides us with the best 5 genotypes according to the best linear unbiased estimators, BLUES. Then, like TD object, in addition to the numerical summaries of the fitted model, the package also provides plots of the model so that we can get a visual summary. Okay? Indeed, 2 types of the plots can be created for the fitted model. The first plot is called base plot. So let's first make a base plot. So we do plot model 1 plot type equal to base and trials equal to 2. Actually, it is a series of 4 plots. The first one is a histogram of residuals, and then the normal quantiles plot of the residuals. The next plot is a scatter plot of the residuals against fitted values. And the last plot is a scatter plot of the absolute value of the residuals against fitted values. And actually, plots can be made for multiple trials and multiple traits simultaneously. But by default, plots are created for all the trials and all the traits. But as you can see, this can be restricted by the argument trials and traits. And the other type of the plot is called spatial plot. Okay. So for spatial plot, we set plot type equal to spatial. Trials equal to 2. Here we get 6 plots.
So the first one is the spatial plots of the raw data, and then the spatial plot for the fitted data, and for residuals, and for blues. And since for this model, we use spots as the engine, so there is an extra plot with the fit spatial trend. Okay. So actually, if we are not fitting a spatial model, then we don't have this fitted spatial trend. Okay. And the last one is actually the histogram of the blues. But actually, it seems like this is the histogram of residuals instead of blues. Because if you can see the value, the x-axis, the values, these values do not match these values for blues, but looks like they are the same as the residuals. So actually, this might be a histogram of the residuals instead of blues. And this is how we fit a model to a data set. and then get some summaries of the model. And in next video, I will do the same thing for the second dataset.